Hello students, today I am going to discuss superposition principle. In the case of Coulomb's law, it is used to find the force of a single charge. If the system has n number of charged particles, then how to find out the electric force between the charges? In such a case, we have to use Coulomb's law along with superposition principle. It means Coulomb's law alone is not enough. We have to use superposition principle to add the total force. Okay, let us consider a system. System means any object. The system contains a charged particle Q1 and Q2, Q3 and Qn. Okay. Here there is a force on the charge Q1 due to the charge Q2 due to the charge Q3 up to, if the system has n number of particles, then the force on the charge Q1 due to nth charged particles. So how to find this total force on the charge Q1? So in order to find the total force on the charge Q1 along with the Coulomb force expression, we have to use superposition principle. What is superposition principle? The force on the charge Q1, it is equal to vector sum of the forces due to the charge Q2, Q3 and up to Q1. So this is called superposition. For example, the force on the charge Q1 due to the charge Q2. Force on the charge Q1, that's why I am writing 1, due to the charge Q2. So F12 is equal to 1 by 4 pi epsilon naught Q by here Q1 and Q2. So Q1 and Q2 by R square. Here the distance is R21. It means the force acts from the charge Q2 to Q1. So we have to use R21 square into R21 cap. This is the force on the charge due to the charge Q2. Similarly, we can write the force on the charge Q1 due to the charge Q3. F Q3 F1 3 is equal to 1 by 4 pi epsilon naught. In this case Q1 and another charge is Q3 by, here the distance is R31. So R31 square into R31 cap. So vector, so we have to use vector symbol. Force the vector quantity. So similarly we can write up to nth particle. So I'm going to write F1n vector is equal to 1 by 4 pi epsilon naught Q1 and Qn by R. Here the distance is Rn1. So Rn1 square into Rn1 cap. Now I'm going to apply the superposition principle, that is the force on the charge Q1. So that I'm going to use F1 total. It is equal to vector sum of forces due to the charge Q2, Q3 up to Qn. Here the vector sum is F12, F13 and F1n. So F12 vector plus F13 vector plus, so this equation you can write up to the nth particle. So F1n vector. Okay, now let us substitute the value F12 and F13. Here the value F12 is 1 by 4 pi epsilon naught. Here the value 1 by 4 pi epsilon naught is a constant. Here also the 1 by 4 pi epsilon naught is a constant. So instead of 1 by 4 pi epsilon, we can use K symbol. That is a constant K. In all the three equations, K is a constant, so that I am going to take K common. And then write the remaining things. Q1 Q2 by R21 square and R21 cap, and then plus second one Q1 Q3 by R31 square R31 cap. So this equation can be written up to nth particle. So Q1 Qn by Rn1 square to Rn1 cap. So here F total vector. So there is a superposition. So the force on the charge Q1, it is equal to vector sum of the forces due to the charge Q2, Q3 up to Qn. So here we are using Coulomb's law and as well as we are using superposition principle in order to find the total force due to a system of charged particles. If the system has more than one charged particle, then we have to use Coulomb force equation along with superposition principle. In this case, where k is a constant, or you can write 1 by 4 pi epsilon naught. So both are same only. So instead of k, you also can write 1 by 4 pi epsilon naught. Or you can use the constant k here. So this is called superposition principle. So by using superposition principle, we can find the electric force on a charge Q due to other charges.